Hi everybody, this is Tor Storley and I am back with another video. In this video, I want to take a look at how you can use some of the built-in functions in DuckDB. And they have quite a bit of functions actually. And I will focus in the financial calculation area because, that's an area that I like. In addition to displaying functionality in DuckDB, I would also highlight a couple of those new features that are coming out with the version 1.1. So what I have done here, and I just want to get that out of the way, in my script here, I'm giving a reference to this PerformanceAnalytics GitHub repository for this R package that are kind of the backbone of some of the functions I'm going to be demonstrating. And right here, I'm displaying a copyrighted statement that I want to show so there is no problems with me reproducing the results in this package. Now, all it requires is whatever the licensing that they set forth there is, but I just want to make sure that everything is on the up and up, and I don't want to violate any copyright information here. So look at my screen. This is what's in the package and one of the files that I looked at out on GitHub. And if you want to go to this package, you can go here. And when you do that, you click in. And let me see if I can open a web browser and actually show you this. All right, you can see this Performance Analytics package in R has a bunch of R functions. And you can see them out here. They are CAPM, they are adjusted premium, adjusted sharp, all kinds of stuff. There's a gazillion functions in here. And if you watched my last video, when I incorporated DuckDB into R, I used something called TidyQuant. It's a wrapper package around, one of the packages wraps around is this Performance Analytics package. That's been around for a long, long time. But it has all kinds of financial performance and financial calculations you can take advantage of. And this is a package that are used by professionals around the world. So this is not a child package. This is a real thing. So if you dig into this one, you're going to find a lot of R code and you're going to find a lot of functionality. If you're not in finance, it might be hard to understand. But if you have some financial background, you might be able to relate to some of this stuff. So anyways, what I want to do, just to demonstrate the functionality in DuckDB, and I'm by no means are going to be digging into all of this, but I'll dig into some of the stuff, some statistics, some calculations that you find in some of these functions and some of these tables or what have you. And at the same time, I want to demonstrate some of the functionalities in the version 1.1 you can take advantage of as well. So that's the purpose of today's video. I hope you like it. And if you do, make sure you give me a like and maybe subscribe to my channel. And I'll mention that later anyway. So for now, that's the idea, what we're trying to do. Use the background of this package, the calculation of this package, but use the DuckDB functionality to try to do so. Okay, so what I have done is I created this script. In this video, I like to take a slightly, a different turn. I always use the DuckDB CLI. And in this case, what I want to do is I want to try one of the other tools that are available to me. What I did was I downloaded something called the dbeaver, which was kind of suggested by DuckDB as a GUI you can use. And if you look at it, it's a tool that looks something like this. If you go into Window Preferences here, and you can set up your dev style, color theme, and you can choose, from all these different themes. Now I settled on this one, dark gray, dark is dark kind of theme. And I also set the user interface appearance for the colors and fonts. And I changed a couple of these guys because in my query, I want to see certain colors for, keywords in your SQL statement, etc. But there's a lot of options here. You can go in and you can apply it and you can So download the dbeaver. It's a free version, and then there's a paid version. Of course, I'm using the free version, and it looks something like this after I applied my themes. Create, new connection, and I'm pointing to DuckDB, the driver, and then what I do is I select whatever path is, and you point to one of your DuckDB instances, and that's how you connect. I already did this. I'm not going to do it again. Another thing I want to say to you is this. If you type in the word progma version, like this, and you hit Control Enter in my Windows version of this software, you can see it's pointing to version 1.1.3. Now, out of the box, it might not. It might point to your 1.0 version. So how do you get it to Progma version 1.3? Well, one thing you can do, you can go in to this database, to the driver manager here, and you choose DuckDB from here, and you say Edit. And once you get in here, you want to pick the right driver. And the one that I chose was the new driver. So how do I get that? Well, what you can do is, you see libraries, driver properties, advanced parameters. If you go to libraries, you see that? Libraries, and you click download or update. Download dash update. You see that? Here, what you want to do is you want to select the latest driver. Notice this JDBC, this Java database connector, is sitting at version 1.1.3. And the reason it's sitting there is because I selected this. And I say download it, and it will install it for you, and then you'll be up to the latest version. So don't forget this step. Otherwise, some of this code will not work, because I'm using version 1.1 for some of this code. So now you know how to get the latest driver for the latest database that you're connecting to. And for me, that's this stocks database. And in this system, you have different settings, but one of them is called main, and that's typically where it puts it. So if you look at the tables, you can see here's my stocks table. I created another one that you understand how that works later. But I also created, like things like procedures. And if you look at some of these, and if you watch my previous videos, you might recognize some of these names if you scroll down here. But what I'm getting at is that there are DuckDB objects, and you'll be able to see them here, or it might be hard to find them. I don't know. Okay, so what are we going to do here in this video? Well, I want to use the dbeaver version 24.1.3, and I'm just going to run DuckDB statements. And I have a file like this, as you can see. It has all kinds of code, and that's the code. There are code that I already ran, but I will still show you. If you were running in the CLI, it will look something like this. You will do dot open, and you will point to your database wherever that is. Now, in my case, it happens to be on this path, and I'll call it stocks. Okay? Now, inside the stocks database, what I happened to do was I created a table, and it's called stocks. And notice the syntax: table, if not exist, create it. Otherwise, don't bother. And it has this kind of structure. And the reason for that is because I'm using my own version of a Yahoo Finance call that I'm getting data from Yahoo Finance and put it into this table. And I also have a return column that I'm not populating initially. So that'd be a null-based column as well. The next thing I do is I describe that table. So once you create that table, you can do a describe stocks. And remember, I already have this, so I'm not going to redo it. But you can see what it will look like inside dbeaver. Symbol, timestamp, open, high, low, whatever. Return, and notice it's nullable. So that's why that is null initially. Now what I'm doing here is I'm stepping through the steps you want to step through. And I'll probably make this file available for you, so in case you want to run your code on your own, you can do so. But I won't run it all because I already created it and I don't want to screw up my script. Let me just paste in what is needed. So here, here is my homemade get Yahoo data function, and I call it get Yahoo data 1. You pass in some kind of symbol, some kind of interval, and some kind of range. And these kind of things I've been discussing in my previous videos. So in case you wonder, go and look at those. But let me just quickly show you kind of what I'm talking about. So if you look at symbol, interval, and range, right? The symbol will be whatever the symbol you're passing in is. The interval will be whatever time frame that you're expecting the results to come back at. And in our case, it's going to be daily data. But you can also pass in the ranges. So depending on how much data you want to come back, 1 day, 1 week, 1 month, 3 months, 6 months, 1 year, what have you. And that's what that one is doing, is loading this JSON from the Yahoo Finance API. And that's all I'm doing here. This is the Yahoo API that I'm building on the fly, depending on whatever your symbols are, like this, whatever you're passing in. And I'm concatenating this string, looking for the interval, which is going to be 1 day. And the range might be like 2 years or 3 years. And then I'm pasting the rest. So I'm running a query against this JSON object that is coming back from Yahoo Finance. And then I'm finalizing it up here by converting the Unix or epochs timestamp into a real timestamp. So that's what this function is doing. Okay, I'm not going to spend more time on this because if you want to understand this function better, check some of my previous videos that discusses this. Then what I do is I run some insert statements. So let me just remove this function. After you create this function, you can call it by saying, hey, insert into this table that we created before. Here's all the columns you need. And where are you going to get the data? Well, you got to get it from the Yahoo Finance macro or function that you just created, right? It was a function in our case. You're going to pass in some kind of symbol, which is APL, Apple, NVIDIA, Tesla. So I'm running it 5 times here. 1 day is going to be the daily dates for the data over a 3-year time period. So that's how you're going to load that table. The next thing you're going to do, because the results you're getting back sometimes when you load the S&P 500, hat sign, and GSPC, because of that, you don't want to keep that in your table like that. So one thing we can do, we can update that and we can set the symbol equal to whatever there's a quote, because it comes back with a quote for whatever reason, surrounding like quote AAPL quote. I don't want that. I want nothing around it. I just want it clean. And also I want to remove that hat from the GSPC. So by running these 2 updates, you get rid of that stuff. So that's what you want to do. If you do see the word date for your timestamp, this is a way you can run it, and it will rename that column to timestamp. And the reason I'm doing that is because I want to be consistent. So that's one way you can do the alter table. You can also, if you're getting a column back called adjusted, like this, you can rename it to adjusted close. And I only do this because I want to have a clean table that I can use throughout my functions. All right. So the next thing then would be, how do I calculate those returns? Remember, in that return column, if I do a from, no, it's not going to work because I already filled it. But what I'm saying is that if the return column, this one, is null, which it will be when you create that table, you still need to create the function that will calculate the function. Now, this is called the ln function, and this formula is identical to what you will find in Excel. If you want to calculate rate of return in Excel, this is how you do it. You take the current rows adjusted close, and you divide it on the previous row. But because I'm in a database, I have to use a function. So I'm using a lag by 1, okay? The default will be by 1. So I don't have to specify that. But in many databases, you might have to, I don't know. So, and then I partition by, which means I group it by symbol, and I order by timestamp. So what that will happen is it will find all the symbols that are AALP, and it will group it by the timestamp, ascending order, and then it will compute, take the current row, which is be row 2, divide it on the row 1 for the adjusted close, and that's how you compute this. So the rate of return using what is called a continuous compounding rate of return, or sometimes called, in our case, in the performance analytics, it's called a log return. So it's the same thing, continuous compounding rate of return or log return. So that's how you do that. Then what you can do, since the first row in your data set will always be null, because you take the second row, divide it on the first row to get a percentage rate of return. Therefore, you don't need those. So let's remove those, and you do it this way. Now what I can do, now that we have prepared this table, I should be able to run something so you can actually see it. So let me do a limit of 100 here. And as you can see, this is what it will look like. I get the symbols here. I got the timestamps here, the adjusted close, and then the rate of return. And keep in mind, the rate of return was computed from taking this, take the natural log of this, divided on this should be this. And that's how you compute the natural or continuous compounding rate of return, which is the preferred method in finance for calculating rate of return. Okay, and then if you want to export to Excel or CSV, you can easily do so by running something like this. For example, select from all the stocks the data, and then you want to pass it in to this CSV file, and you want to pass in the header, delimiter, and the delimiter would be this one. So that's how you can create a new CSV file, which can be, useful if you want to work in Excel, for example. One more thing I want to show you is this. Now, in DuckDB, you can use functions, right? A gazillion functions in DuckDB. One of them is called last day, as you can see. In my timestamp data here, if you look at it, if I highlight this and I do a control enter, notice 11/9, 11/10, 11/11, 11/12. So it's daily timestamps, right? So how do I get monthly timestamps? Well, one thing I can do, I can say last day of this timestamp. That will find the last day of this particular month, right? So if I run that, if I run this whole thing now, notice I'm getting 11/30, which is the last day of November, and the last day of December is 31st. The last day of January is 31. Last day of February is 28. So this will give you a way, if you want to use these kind of functions, where you can get the last day of the month. So that's one possible way. Now, in this next section, I am going to start showing you some functions. These may or may not be new functions, but I think they're still very, very interesting. So let me show you. What you can do is, this first function here, I'm going to use this any value function, okay? So we're dealing with lists. And as you can remember from previous videos, we used unnest. So we're going to look at any value and unnest. What I'm doing here is I'm using my regular way of doing things. I'm using a CTE with some name, S, and here's the query. So now I got a name for that CTE. Then I build a second CTE, list 2. The only difference now, if you nest them like this, put a comma here and give it a name here, but don't use the with clause. That's only for the first one. Now, what I'm doing here is I'm saying select star from values, and then I'm passing in some values. Now, the whole purpose here is to find all the values where it's not null. So in other words, I want to find out at what point is this particular query going to return a not null value. And obviously, you can see it happens here, right? And then you can use this kind of syntax where you say as t, you could say t or t value, what have you. Here's list 2, which is the second CTE. And in this case, you can see it turns not null right here. So then I can say from these 2 CTEs, give me back my first not null value. It's almost like a coalesce function in other databases. So when I run this now, you can see first one is 3, which makes sense. It's this one. The others were null. Here from this list is 20 right here because the first one was null. So it produces the first not null value. So that's what that particular function is doing. Okay, in the example 2 here, let me just run through these examples and then we'll move on to something more complex, I guess. Here, I have a few examples. So this is when you're dealing with lists or array ags. And again, if you wonder, just go to aggregate functions and search for, lists or ag or whatever. Here is one way you can actually query a list in DuckDB. Let me make this a little smaller. Okay, so what I have here, if you look at it, I have a select value from, and then I'm querying it from this, which is basically just value. So this will be like a regular style query. So if I run this, you can see I'm getting the values, Tor, Jerry, Sandy, Barb, and Jenny, which is I have listed in my values section. Now, another way I can do this, I can create an actual list like this and give it a name and then query out the name. Now, this is like a list object. So let's see what that will look like. Notice now it comes back in a list format. So that's not necessarily what I want, but let's leave it that for now. Now, this one, I'm not sure if it actually works. It didn't work. So let me get rid of this one because I don't think this one really works. And I don't really need it anyway. Now, one thing I can do too, I can use this unnest function. Remember this query right here? It comes back in a list format. If I want to unpack that format into columnar format, I can simply use this unnest function. And notice now I'm getting all the values back in one row for each value. Final example I want to show you of the small examples is this example. So let me just Control A, Control V. And what this one do is it's a little tricky to understand, but it's part of the, I don't know if it's part of the new version or not, but it's an introduction to the new version. And I'll show you more about this when I get into my bigger functions. But notice this, I'm creating a symbol and I'm calculating a max from any columns in this table that are not named symbol and not named timestamp. So basically what it does is it say, hey, select every column in the table, but do not select symbol column and timestamp column, because it doesn't make sense that you find a max value of a data symbol, like a ticker symbol, or a timestamp. Well, maybe a timestamp, but I don't want to see it. I want to see it on double columns from this table. Now, in case you wonder, you can say from stocks and just run it. Notice you have symbol, you have timestamp, and then you have all these double columns, open, high, low, close, volume, close, return. Maybe I want to see the max and the min, or in this case, just the max from each one of those. So it doesn't make sense to choose a max symbol because What is that going to be? It will just be alphabetically ordered. So in order to do that, you can use this columns function and use a regular expression that says, do not choose symbol, do not choose timestamp, choose all the other columns and calculate the max from them. And when you run it, it looks like this. You got Microsoft, and the reason you see the symbol is because I selected it separately. Now, if you didn't have this, it would look like this, and you wouldn't know which stock it belongs to. So that's why I chose the symbol, and then I used this column function. So it's very powerful because you can actually run aggregations over many, many columns. You don't have to actually list, and you can also exclude columns like this. So it's a super powerful formula of using some of the more newer functionality of DuckDB. Okay, so in the next part in this series, we're going to look at some more functions, and we're going to do some more analysis on some of these financial data. If you like this video, make sure you give it a like. It really helps. Otherwise, not too many people will see it. And consider subscribing to my channel if you haven't done so already. I'll see you in the next video. Have a great day, great night, wherever you are in the world.